Hello Legacy Sabers, Marsh here. So today we're going to talk about even and odd functions. Some stuff that we're going to basically be looking at. We're going to be basically looking at symmetry with graphs today. You guys kind of done symmetry. Kind of done symmetry about with shapes and all that, but now we're going to look more at functions in that regard. The learning objective for this lesson today is I can identify an even or odd function using a graph or algebraically. Now, something to do. Learning objectives. I would write them right at the top of my page of my notebook. What that's going to be used for is so that when you're flipping through your notebook to try to find notes on anything for like a review, that will make it easier for you to be able to find that particular set of notes. Also, the learning objective is going to be helpful to connect with the summary that we're going to be doing when we get back to class. So, even and odd. What does it mean to be even or odd? Even functions have y-axis symmetry. What does that mean? Ultimately, it means that if I have one side of my graph, this guy, I'm going to have a guy also on the other side that's going to mimic the right-hand side. So that means if I would fold along the y-axis, they would line up perfectly amongst each other. Another way to put it in more algebraic terms, if you want to say it that way. So for an even function, for every point x, y on the graph, you're going to also have to have the point negative x, y on the graph. So if I have the point 1, 2, I also have the point negative 1, 2. Kind of like that, because all you're doing is flip-flopping the x's sign around. You're not changing the y value at all. Now, origin symmetry. What does it mean to have origin symmetry for odd functions? What that means is that they are able to be between the y equals x line. So they're basically around the origin. Now, how to tell that graphically? It's kind of difficult. Here's how I like to think of it. What I do is I will take the graph, one of the sides, reflect it across the x-axis, and then reflect it across the y-axis. It should line up with the other side. Let me repeat that. To check for symmetry, reflect across x, then across y. If they meet up, that means you have origin symmetry, which means it is an odd function. Now, what about algebraically? What it means to be an odd function is that for every point x comma y on the graph, I have a point negative x, negative y also on that graph. Now, what about x-axis symmetry, you're probably saying? Is that like some other word than even and odd? No, it's not. Because x-axis symmetry is not a function, right? Because that doesn't pass the vertical line test right here. Doesn't pass the vertical line test. Can't do that. So wouldn't it be a function for me to do that kind of symmetry? And we're only going to be looking at functions today for even and odd, not anything crazy that's not a function. Now, let's look at the algebraic way to do this. A function is even if f of negative x is f of x for every number of x in the domain. Now you're probably saying, whoo, Marsh, that's a mouthful. Let me give you in actual terms. If you plug a negative x into the function and you get the original function back, no signs changed, nothing, that function is what's known as even function. Let's take a look at a function here. So I have f of x equals 5x to the fourth minus 2x squared plus 1. So what we'll do is we're going to take negative x and we're going to substitute it for x. Because that's all this is right here, is into f, you're going to substitute negative x. So let's complete that here. So I have f, I see an x, got to put a negative x there, minus 2, see an x, put a negative x, plus 1. Now, let's think about it. If I have negative x to the fourth, so negative 2 to the fourth, that's going to be a positive, right? No matter what that is, it's got to be a positive number. Even if it's negative 2 with a negative, if x is negative 2, so then it would be negative 2, that would be a positive 2. This means, so would you agree with me, that this would always be a positive x to the fourth, no matter what it is. So that means that that's got to simplify down to 5x to the fourth. Same thing here, negative x squared. That can never be a negative number. It's got to always be a positive, no matter what I substitute in for x. So that's always going to be negative 2x squared, and then that plus 1 is going to stay the same. Now, we'll take a look here. Once you've done that substitution and you've simplified, are they the same equation? Same function? Same thing? In this case, take a look. They are. So what we can say is this graph is, or function for that matter, is an even function. If you take a look at the graph, got a picture over here. Notice, guys, even means it's a y-axis, has reflection about the y-axis, or symmetry about the y. And if I fold along the y-axis on this function, they will line up perfectly on top of each other. So it's cool when the algebra and the graphically kind of meld together. Let's try another one. So I have f of x of 2x cubed minus x. Let's take negative x and plug it in for all of my x's. So I have 2 to the negative x cubed minus, got another negative x. Now, let's see if we can simplify, kind of like we did up here. Negative x cubed. So that'd be like negative 3 cubed. That'd still be a negative x, wouldn't it? Negative x cubed. Yeah, that's what it would be. So, that negative is going to have to stay, which means technically I'm going to have a negative 2 sitting here, x cubed. Because we got to care about that negative. It's not going to matter if it's in front of the 2, though, because that's always going to turn out to be a negative. Then I have this double negative here, and so I got plus x. Well, I simplified. It's not the same. Not at all. So if I look at the graph here, that's definitely doesn't have symmetry about the y-axis. So, definitely not an even function. Definitely not even. Let's take a look and see what it means to be odd. So here's the formal definition in blue. A function is odd if f of negative x is equal to negative f of x for every number of x in the domain. Simpler English. If you plug a negative x into the function and you get the negative of the function back again, aka all terms have changed the signs, you have an odd function. Let's try a couple. So I have 5x to the fourth minus 2x squared plus 1. Same thing. Both testing for even and odd, you always have to plug in a negative x. So I'm going to plug in a negative x here. So I have 5 negative x to the fourth minus 2 times negative x squared plus 1. Had this conversation on the last slide, but if I take a negative x to any even power, you are going to just get a positive x back out. So in this case, this will be 5x to the fourth. This will just be x squared. and then I got plus 1 here. So now noticing here, these are exactly the same function, no difference. So this cannot be an odd function, not odd. It's actually even. So if I look at this graph here, it did have y-axis symmetry, not origin symmetry. So let's take a look at another one here. I have f of x equals 2x cubed minus x. Let's plug in our negative x here. So I got 2 negative x cubed minus negative x. So just like how I had my even powers, my odd powers are going to keep that negative with them. So I'm going to get negative 2x cubed, and that's going to be a plus x, right? Double negative. Notice, 2 became negative, negative x became positive. All the signs changed, nothing else. No numbers changed, no nothing else, just the signs. This is an odd function. All the signs have changed. If only one changes, that's not odd. All of them have to be changing for it to be odd. It's odd that they all changed in the function. If I look at the graph now, remember odd meant it was origin about, or symmetry about the origin, which means if I flip one side here about the x, which would be making it going like that, right? And then I reflect across the y, I'll get that. So it'll line perfectly up together. Now, if a function is not even or odd, we just say it's neither. So now, here's the thing. You cannot be both even and odd. That doesn't work. You're either even, you're either odd, or you're neither. Can't be two of them. You can only be one. So let's try a couple on here. We're going to determine, are you even, odd, or neither? At 5x cubed minus 1. How are we going to start this? You're going to take a negative x and plug it into the function. So 5 negative x cubed minus 1. Just like we spoke about earlier, if I have an odd power, we're going to take the negative, it's going to have to stay. So this is actually negative 5x cubed minus 1. Okay, plugged in negative x. Let's take a look at all the signs. They're definitely not the same, right? Because the 5s and the negative 5 changed. But not all the signs changed. This is a neither. Not all the signs changed, and I didn't get exactly the same thing back. Let's do another one. Last one for this video. Negative 3x to the 4th minus x squared plus 2. Let's take and plug in a negative x. There we go. Negative x to the 4th. Well, that's going to be a positive x. This is going to turn into a positive. But there's a negative there, so it'll just be positive x squared plus 2. Match, match, match. Even function to end out the night. And that's the end of this video. See you later, Sabers.